Welcome to The Explainer. Today, we are digging into what is maybe the biggest question in tech right now. Can these new AIs actually think? Okay, so let's just jump right in. We're in the middle of this AI revolution, right? And the newest models claim they don't just spit out an answer. They show their work, this whole thinking process. The question is that real reasoning, or is it just a very, very convincing magic trick? Well, to get to the bottom of that, we're going to break down this really incredible paper from a team of researchers at Apple. They basically built the ultimate stress test for these so-called thinking AIs. And what they found, honestly, it might change how you see AI altogether. So first, let's just frame the problem here. When an AI lays out its chain of thought, is it actually building a logical case from the ground up, like a person would? Or is it just really, really good at mimicking the patterns of thinking it learned from all the text on the internet? And that brings us to the main characters in this story. Large reasoning models, or LRMs. You've definitely heard of them. Think OpenAI's Golan-1 or Claude 3.7 thinking. Their whole selling point is that they generate this long, step-by-step trace of their logic. And you have to admit, it looks a whole lot like human reasoning. It feels like a huge leap forward. But, and this is a big but, the researchers argue that the way we test these models is just broken. Think about it. If you give an AI a math problem from a standard test, there's a good chance it's already seen that exact problem and its solution in its training data. So is it really solving it? Or is it just remembering? Okay, so if the old tests are no good, what do you do? Well, this is where the Apple team got really clever. They decided to build a whole new testing ground, kind of like a clean room laboratory for an AI's brain. And here's the genius of their approach. Instead of using problems the AI could have memorized from the internet, they use classic logic puzzles. These are puzzles that are definitely not in the training data. And this is the crucial part. They could precisely control the difficulty, cranking it up notch by notch to see exactly where the AI's logic starts to crack. They didn't just pick any puzzles either. They chose 4 classics, and each one is designed to probe a different kind of algorithmic skill. You've got the Tower of Hanoi, which is all about careful step-by-step planning. Then you have things like the river crossing puzzle, which is about juggling a bunch of tricky rules. These weren't just games. They were surgical tools designed to find the breaking point of AI reasoning. All right, so they set up the lab, they've got the puzzles, they let the AIs loose. And the results were not what you'd expect. It wasn't as simple as the thinking models are better. Instead, their performance broke down into 3 totally different stages, all depending on how hard the puzzle was. So check this out. For the easy puzzles, the regular, non-thinking models were actually better. They were faster and more accurate. But then, as the difficulty got into that medium sweet spot, the thinking models, the LRMs, took a clear lead. Their chain of thought process really seemed to help. But then, when the puzzles got really hard, something else happened. They all just failed. A total collapse in performance across the board. So, wait a minute. Why would a thinking model be worse at easy stuff? Well, it turns out they have a bad habit of overthinking. The researchers found that on simple problems, the LRM would often figure out the right answer right away, but then it would just keep going, exploring all these other useless paths, burning time and energy for no reason. Okay, but let's talk about the most stunning part of this whole thing, that third stage. What happens when you push these super advanced AIs past their comfort zone and into truly complex territory? It's not a gentle slope down. It's more like driving straight off a cliff. And the numbers here just tell a brutal story. As the complexity of the puzzles goes up, the accuracy doesn't just dip, it completely tanks, hitting absolute zero. I mean, think about that. Past a certain point, the smartest reasoning models they tested couldn't get a single puzzle right, not one. But this is where the story takes a truly bizarre turn. You think, okay, harder problem, the AI must be thinking harder, right? Pouring more resources into it? Nope. It was the exact opposite. As the problems got tougher, the models actually started to think less. What this points to is a pretty fundamental wall. When the problem gets too tough, these models don't try harder. They seem to just give up. They literally reduce the amount of thinking they do, even when they have all the processing power they need. It's almost like they know they're out of their depth and just quit. So what in the world is going on inside that black box, during that so-called thinking process? Well, because they built the puzzles, the researchers could actually peek inside the AI's internal monologue and watch every single move it made. And this table really lays bare the model's flawed strategy. On easy problems, it finds the right answer but keeps wandering around. That's the overthinking. On medium problems, it thrashes around, trying a bunch of wrong ideas before it finally stumbles on the solution. And on the hard problems, it never even finds a correct path to begin with. Its ability to course correct is just fragile, and under pressure, it shatters. But let's get to the final experiment, because this is the one that really unravels the whole idea that these AIs think like we do. This is the moment where the illusion becomes crystal clear. You have to hear this. The researchers gave the AI the ultimate cheat sheet. I mean, they literally spelled out the exact step-by-step algorithm to solve the puzzle, right there in the prompt. And you know what happened? Nothing. It didn't help at all. The AI still hit the wall and failed at the exact same point. I mean, just let that sink in for a second. The AI had the perfect recipe, the exact instructions, and it was still incapable of following them. That strongly suggests it's not understanding the logic of the puzzle. It's doing something else entirely, something that feels a lot more like sophisticated pattern matching than a true generalizable problem-solving skill. So what this research really reveals is a hard ceiling. It shows that today's large reasoning models, as impressive as they are, haven't yet cracked true general problem solving. When you put them in a new situation with complex rules, they don't just get a little worse, they completely break down. Which leaves us with this pretty profound question, right? When we see an AI generate pages and pages of complex thought, are we actually watching a new kind of mind at work? Or are we just marveling at an increasingly perfect and powerful illusion of one? After seeing this research, the line between the two seems blurrier than ever.